Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to go over Lewis acids and Lewis bases. So yes, this is a third definition of acid and base. So the first one we went over was the Arrhenius definition of acids and bases, and that was basically defined by whether or not it produces H plus or OH minus. And then we went on to the Bronsted-Lowry definition of an acid base, which was focused on whether or not the substance or species was a proton acceptor or proton donor. Now, what we're going to be focusing on is not so much whether or not you're an acceptor or donor of protons, but whether you're an acceptor or donor of electron pairs. So this definition was given to us by G.N. Lewis, the same guy who gave us the electron dot structures. And so, as I said, his definition is focused on the transfer of an electron pair rather than the transfer of a H plus or a proton. So in using his definition, if we have this equation here or this reaction going on here, we have an H plus, and it doesn't have any electrons, no electron pair here. But here we have NH3 that has an electron pair. So we can see this, we can understand this as the NH3 donating the electron pair to the hydrogen, and the hydrogen is accepting that pair. So therefore, the electron donor, so NH3 as the electron donor would be the Lewis base, and H plus ends up being a Lewis acid because it is accepting the electron pair. So by his definition, a Lewis base is now an electron pair donor, and a Lewis acid is an electron pair acceptor. So although these definitions don't really expand significantly the substance considered as bases, because as we can see here, a Lewis base is also is a electron pair donor, but it is also going to be a proton acceptor. So by the Bronsted-Lowry definition of a base, so NH3 is a base, but also by the Lewis base definition or the Lewis definition of a base, NH3 is still a base. However, according to the Lewis definition of an acid, it does greatly expand the acids that the substances that we would call acids. So it does significantly expand substances considered as acids. So for example, we have BF3. So BF3 is now considered an acid in the Lewis by the Lewis definition because it is going to accept the electrons. We have an electron pair by NH3 again. So the electron pair can be accepted by BF3. Why does the BF3 can accept the electron pair? It's because it has an empty orbital that can accept those two electrons. So having an empty orbital or being able to rearrange your electrons to have an empty orbital will now make you an acid according to the Lewis definition of acid. So here again we have the BF3 acts as a Lewis acid, NH3 acts as a Lewis base. It is donating the electrons to the bromine or boron. And so we get this substance here, which is called the adduct. The adduct is a product of a Lewis acid reacting with a Lewis base. So whenever you get a product from that reaction, you would call that an adduct. And so one of the things we want to keep in mind that I just mentioned a moment ago is a Lewis acid has an empty orbital. So if your element has an empty orbital, then, or if it can rearrange the electrons here, if it can rearrange the electrons to create an empty orbital, then that can accept an electron pair. So being able to have an empty orbital or rearrange to have an empty orbital will allow you to accept an electron pair, and therefore you now become an acid according to Lewis' definition of an acid. So let's go over some examples of how this would work. So here, molecules. If we have molecules with an incomplete octet, those empty orbitals can receive the electron pair and therefore act as Lewis acid. So here's a couple of examples. So we have aluminum chloride and boron trichloride. So here we have aluminum chloride here. So it has an empty orbital. It can accept electrons. So the lone pair, the electron pair here in the ammonia, can then be donated to the empty orbital, and then you create a bond. So now this is acting as the Lewis acid, and this is the Lewis base. So now this is an acid. We have the boron trichloride. So here again, boron has an empty orbital. Here we have lone pairs on the oxygen. One of those lone pairs can be donated to the empty orbital on boron, and we can get a complex here, a bond here. So now this is acting as the Lewis base, and this is acting now as the Lewis acid. And as I said a moment ago, if you don't have an empty orbital, if you can rearrange your electrons to create an empty orbital, then that will allow you to be an acid as well. So here we have this example of water with carbon dioxide. So how do you get, when you add carbon dioxide to water, we all know we get carbonated drinks, and then that forms carbonic acid. So how does that form? So here, we don't have an empty orbital in the carbon, but the lone pair here can attack the carbon here. And what happens is the electrons in the bond here of this orbital will move to the oxygen, and then thus you can form a bond here. So then it creates an empty orbital, and that can accept these electrons, and now you've got a bond here. And so now you can see that this oxygen has 3 bonds and 1 lone pair, not favorable for an oxygen, but this oxygen has 3 lone pairs. So the 1 lone pair can then act as a donor to this hydrogen. So they're going to move over there, create a bond, and now the electrons in this bond can go on to that oxygen. And so now we have 2 lone pairs here, and the hydrogen now is bonded to this oxygen, so we have that. And so now we have our carbonic acid from adding carbon dioxide to water. So here we have a rearrangement of electrons to create open orbitals or empty orbitals that can accept the electron pair from a Lewis acid. So water here ends up being the Lewis base, and then carbon dioxide here is the Lewis acid. Okay, so finally, what about certain cations can also be Lewis acids now? So here we have aluminum. We've seen this before in a previous video where aluminum can form a complex with 6 water molecules, and that allows for the aluminum to make the solution acidic. So here, aluminum has empty d orbitals. So here we have the electron pairs on the oxygen. So those 6 those 6 waters can donate electron pairs to the aluminum, and so thus being an electron pair acceptor, aluminum now becomes the Lewis acid, and being the electron pair donor, water is the Lewis base, and we form this complex with aluminum and water. So that's Lewis acids and bases. I hope this was helpful and interesting and helped you with anything related to Lewis acids and bases. If you like my video, please hit that like button, subscribe to my channel, hit that notification bell so you can be notified by other videos I put out. Put a comment down in the comment section. Let me know what you think and if you've got any questions for me. Thanks for joining me. Have a great day.